Hey everyone! In this tutorial, we'll make a character hold a specific object and gain full control over the size and placement of that object in space. And of course, we'll ensure it keeps its appearance. We'll be using the FLUX.1 Kontext model in the ComfyUI environment. Some of you who've worked with this model might say, it's pretty straightforward. Just take a basic workflow with two images and tell the neural network to make the character from the first image hold the object from the second image. Yes, that's right. For example, if it's a cup or a sword, this method works great. But what do you do when the object's size isn't obvious? What if it can range from the size of a matchbox to half a wall? This is where things get tricky when trying to explain to the neural network how big or small the object should be. Most likely, even with precise prompts, it'll average things out, fitting the object to some standard size it thinks is right. But in this tutorial, we'll solve that problem. This video is the second part of a guide on Flux Kontext. You can watch the first part via the link above. In the third part, coming soon, we'll cover workflows for face swapping and changing clothes. Subscribe so you don't miss it. All right, let's get started. Currently, the FLUX.1 Kontext model exists in several versions. The original format from Black Forest Labs requires a GPU with at least 24 gigabytes of memory. The lightweight FP8 version from ComfyUI, the GGUF format, the accelerated Nunchaku version, and two advanced PRO and Max models, available only on paid platforms. In this video, I'll show you how to set up and use the Nunchaku version, as it delivers results comparable to the original Black Forest Labs version, but allows generation on lower-end GPUs and significantly speeds up the process. More on that later. Here's my workflow. The link to it will be in the description. You can either download it or follow along with me by watching this video. If you choose to use the ready-made workflow, just drag the file into your ComfyUI environment, and it'll open. If some nodes turn red, go to the manager, click Install Missing Custom Nodes to install the missing nodes. Check all the nodes and click the Install button. You'll need to restart ComfyUI. But first, go back and update everything, then restart ComfyUI. In the previous video, I showed an example using two reference images, plus an editor for precise object placement. Based on these three images, the composition was created. I tried using the same workflow to have a character hold a portrait of a girl. But despite specifying the portrait's size, I didn't get the desired result. The portrait was supposed to be small, palm-sized, yet the program kept generating various versions of large portraits. The program always tried to make the portrait the size it thought was appropriate. I also tried using words like object or item instead of framed picture or framed portrait to avoid giving the neural network any stereotypes. But the result still wasn't what I wanted. Specifying things like small portrait, palm-sized portrait, or low-resolution small portrait wasn't enough either. The program needed more data. To address this, we'll use a node for compositing images on a single canvas, allowing us to adjust the size and position of objects. Let's break down this workflow in detail. Everything here is standard. Model loaders, Diffusion model loader. My GPU is an RTX 4500 with 20 gigabytes of memory. So, initially, I used the lightweight FP8 model, but later I'll show you the more capable and faster Nunchaku model. Text encoders, VAE model. Here, I assign a VAE variable so I can call it near the node without dragging long lines. This node provides links to all the models, where to download them, and which folder to place them in. Clicking on the model name opens its page. I've also embedded all the model information into the workflow itself. Right-clicking on a node's properties lets you see this information. Now, if you open this workflow but are missing some models, a message will pop up with an option to download them immediately. If you already have the models but they're named differently, just close the window. It won't affect anything. Then select your models. Positive prompt. 0 node instead of a negative prompt. Reference latent. Before it, the VAE encoder. Flux guidance. Key simpler. VAE decode. Here, 2 reference images are used, processed in a specific way. The compositor config node, where both images are fed. The image resizing node. If the image is too large, it'll scale it down. In my case, the original size is small, so the image size stays unchanged. This is just an informational node. Everything related to the first image stays as is, unchanged. For the second image, we need to remove the background, isolating the portrait itself. This is another resizing node. The layer mask, segment, anything ultra node is a powerful tool for image segmentation, allowing precise object isolation and mask creation. Model loader. The following models are used. SAM, a model for automatic segmentation, capable of isolating objects without prior training on specific classes. Grounding Deno, a model for object detection with the ability to use text prompts for more precise isolation. A bit more about this node's parameters. Threshold sets the sensitivity for filtering predictions. Higher values mean stricter selection. Detail method chooses the edge processing method for the mask. VIT mat generates high-quality trimaps, but requires a lot of memory for images. Parameters for shrinking or expanding mask edges to refine them. Black and white point adjusts mask thresholds to refine segmentation edges. Prompt to specify which object to isolate, e.g., person, painting, tree. If you get a message like this when starting generation, it means the composition isn't set up. Just close it and adjust the images, their size, and position. Notice that some areas of the portrait have become semi-transparent. We need to lower the threshold. Let's try 0.2. It's better, but there's still slight transparency. Let's lower it to 0.1. Now it's perfect. Now the interesting part. When running generation, I noticed the program kept drawing either a large portrait, leaving the hands unchanged, or placing a large portrait in the wrong spot. After trying a ton of super precise prompts, I realized the issue wasn't the prompts. The problem was likely that I was using the lightweight FP8 model, which is less capable than the original full-size model from Black Forest Labs. But the original model is too heavy for my machine. I found a solution. Instead of the original, I used the Nunchaku model. And miraculously, it worked, delivering faster results than the FP8 model and quality comparable to the original. Its setup was a bit more involved, but it's worth it. Let's go to the developer's website. The Nunchaku plugin significantly speeds up generation and editing, reduces memory usage with 4-bit quantization, and maintains high-quality results. Look at these images. The first was generated with the original Black Forest Labs model. The last one is Nunchaku. Can you spot the difference? There's barely any. The first took 111 seconds, the last one 12. Memory usage was 22.7 gigabytes for the first, and 6.5 gigabytes for the last. Impressive. Let's move to installation. Go to the manager, update everything, including ComfyUI. Restart ComfyUI. Refresh the page. Go back to the manager and click Custom Nodes Manager. In the search bar, type Nunchaku. Here's the plugin. Select it and click Install. Here, choose the nightly version. Installation starts. Restart ComfyUI. Next, you need to run the install_wheel.json file. This file simplifies the installation or update of the Nunchaku wheel.w.hl library in ComfyUI. It's a workflow for ComfyUI that automates installing the correct Nunchaku version. Go to the developers page and select this workflow. Download it. Drag the file into your ComfyUI environment. Here, it lets you choose the installation source and Nunchaku version. I choose Hugging Face and version 0.3.1. Run this node. An error message popped up. This happens sometimes, probably because I'm reinstalling for this video. Without changing anything, just run it again. Success! It says everything necessary has been installed. The wheelfile.whl is a Python library archive and installs in ComfyUI's Python-related folder, not custom nodes. Close this workflow. Now go back to the developers page and download the workflow specifically for FLUX Kontext. For example, this one. Drag it in. I got a message saying a required node is missing. That's just for me. In most cases, it should open without errors for others. But I had to do a few more steps to get it working. Like a card player shuffling, I had to try different installation versions and methods. Through trial and error, this one worked. In the error window, click Open Manager. I have two ComfyUI versions, Standard and through Pinocchio. In the Standard one, plugin info shows up in the center. In Pinocchio, it's blank for some reason. So I click Installed, and the info appears. Here, it's crucial to choose version 0.3.1. Install. Restart everything and refresh the page. Oops, nothing changed. In the standard ComfyUI build, I succeeded at this point, but Pinocchio is a tough nut to crack. So we keep going. Go to the Custom Nodes folder and delete the Nunchaku folder. This doesn't affect what we installed with the wheel workflow, as that's in the Python library folder. Restart everything. Reload the page with the example to trigger the error window again. Open the manager again. Select version 0.3.1 again. Install, restart ComfyUI. Refresh the page. And voila, it worked! Essentially, we only need the Nunchaku model loader node and the model itself. Follow the link and download this model. It should be in the Diffusion models folder. Return to our workflow. Replace the Diffusion model loader node with the FLUX model loader node from Nunchaku. If you're using LoRA, call the Nunchaku LoRA loader. Not all LoRas may be compatible with this model, so check. Run the workflow. The model handled the task successfully. Keep in mind that the prompt matters a lot here. It needs to be as clear, specific, and concise as possible. I write, keep the young man's figure, position in space, body proportions, facial features, and clothing unchanged. Keep the portrait's details, size, and position in space unchanged. Have the young man hold a small portrait in one hand. You can also experiment with the FLUX guidance value. Lower values allow more creativity from the neural network. Higher values ensure closer adherence to your prompt. In this case, try values up to 5. Different numbers of steps can also yield different results. If this video was helpful, give it a like and subscribe to the channel.